Hi, it's Mrs. Mafucci. This year in chemistry, you will be recording two types of data when you perform experiments. The two types of data are qualitative data and quantitative data. Let's consider each. Qualitative data. Qualitative data deals with descriptions. This is data that can be observed but not measured. Examples of qualitative data include color, texture, smell, taste, appearance, beauty, etc. Examples would be the color of the mixture was red. A solid formed when two chemicals were mixed. The product smelled like ammonia. Do you see the word quality in qualitative? Qualitative data is just a description. Quantitative data, on the other hand, deals with numbers. It's data that can be measured. Quantitative data always includes numbers and units. Examples of quantitative data include length, height, area, volume, etc. Quantitative data always involves numbers and units. Do you see the word quantity in quantitative? Well, let's do some examples and see if you can determine the difference. Let's take this oil painting for example. Well, what would be some examples of qualitative data, qualitative descriptions? It's blue-green in color. It has a gold frame. It smells old and musty. The texture shows brush strokes of oil paint. It's a peaceful scene of the countryside. Those are all examples of qualitative data. Quantitative data, on the other hand, would be the picture is 10 inches by 14 inches. You actually measured the length and width of the painting, giving the numbers and the units. The frame is 14 inches by 18 inches. The painting weighs 8.5 pounds. It has a surface area of 140 square inches and costs $300. Numbers and units. What about example number 2, a nice latte? Qualitative data, robust aroma, frothy appearance, strong taste, burgundy cup. Quantitative would be 12 ounces of latte, a serving temperature of 150 degrees Fahrenheit. The serving cup is 7 inches in height. The cost, $4.95. Do you see the difference between qualitative and quantitative? Qualitative is just a description of the quality of the thing you're observing. Quantitative is a measurement that involves numbers and units. Accuracy versus precision. Accuracy refers to the correctness of a measurement. It depends on the quality of the measuring instrument. This year in chemistry, you will be working on your accuracy. You want to measure correctly. You want to give the right answer. When I ask you to find the mass of a penny, you want to be accurate. You want to take care to give me the correct measurement. Precision, on the other hand, is reproducibility. How many times do you get the same answer? In other words, if I ask you to find the mass of a penny, precision would be your ability to get the same answer every time. It depends on our skill as the investigator. Do you follow the same procedure each time you make a measurement? In this class, we want to work on both accuracy and precision. You should know the difference between these two words. Accuracy, how right you are. Precision, how many times you can get the same measurement. Let's look at these pictures below. We want to get the bullseye. In the first picture on the left, you're not accurate or precise. You're not close to the center, and your measurements are far apart. In the middle picture, you're not accurate, you're not close to the center, but all of your measurements are close together. You have good precision. And the final picture, that shows what we really want to get all the time we're making measurements in the lab. Accuracy and precision. All of the measurements are close together and they're in the center of the diagram. What are some measurements we're going to be making in chemistry this year? The first one, length. What is length? Length is defined as the distance between 2 points. How is it measured? It's measured by a ruler. Length would be the distance between point A and point B. What is the basic unit for length in the metric system? The basic unit is the meter. Meter is abbreviated with a lowercase m. A meter is slightly longer than a yard. A kilometer is about 6/10 that of a mile. There are 2.54 centimeters in 1 inch. This is something you should be writing down. Circle it, because eventually we are going to make conversions between metric and English. Well, what about volume? Volume is the space occupied by an object. How is it measured? For example, liquids are frequently measured using a graduated cylinder. Notice that you always read the bottom of the meniscus. Another tool for measuring volume is the pipette. We will be using the pipette this year in chemistry class when I ask you to transfer specific volumes of a liquid. A volumetric flask is also used to measure volume. What is the basic unit for volume in the metric system? The basic unit is the liter. And liter has the abbreviation capital L. Make sure you always use an uppercase L for liter. A liter is slightly larger than a quart. 1 gallon is 3.81 liters. Make sure you write this down and circle it because you will be converting between liters and gallons. Sometimes we need to find the volume of a regularly shaped object. In this case, we are going to use the formulas. Remember, the formula of a cube is length times width times height. The volume of a sphere is 4/3 times pi times r cubed. And the volume of a cylinder is pi r squared h. Don't worry, I will always give you the formulas to determine the volume of these regularly shaped objects. Since we will be using length measurements to determine the volume of these solids, centimeter times centimeter times centimeter. In this case, our units for volume will be centimeters cubed. Now, it's important to know that 1 cubic centimeter is also equal to 1 milliliter. So, a solid with a volume of 1 cubic centimeter is the same as the volume occupied by a liquid which has a volume of 1 milliliter. A cubic centimeter is the same thing as a milliliter. Don't forget that. Now, what about if your solid is irregularly shaped? That means there can't be a formula to find its volume. In that case, we're going to use a process called water displacement. So let's look at this example. Step 1. Add 200 milliliters of water to a graduated cylinder. Step 2. Add the irregularly shaped object. Look at that. And number 3, the difference in the volumes is the volume of the object. In other words, that irregularly shaped object took up space in that original amount of water, causing the water level to go up. Do you see that the water level went up to about 260? So we have 260 minus 200, which is 60 milliliters. That means this irregularly shaped solid has a volume of 60 milliliters. Finally, mass. Mass is defined as the amount of matter. Mass is not weight. Weight is the force of gravity on an object. That means if you're on a planet with greater gravity, you're going to weigh more. Mass is defined as the amount of matter. Mass is measured using a balance, not a scale. A scale measures weight. A balance measures mass. What is the basic unit for mass in the metric system? The basic unit is the gram, abbreviated little g. Now, 1,000 grams is slightly larger than 2 pounds, and there are 454 grams in 1 pound. You should circle this because you're going to have to be able to convert between grams and pounds.